In this video, we are going to deep dive the basic concept of self-attention, or the attention that is used in the transformers neural network. It is based on the this whole video will be based on the paper Attention is All You Need. Attention is All You Need is a state of the art paper that conceptualizes the transformer architecture, a neural network model for NLP tasks that relies solely on attention mechanism to process the input sequences. So, what is attention? Is a thing we have to understand first. Attention is a mechanism that allows neural networks to assign different amount of weight or attention to each element in a sequence. So if we are given input sequences, that is a token. In our case, for the text sequences, the elements will of course be the text embedding or the token embedding of the some dimensional. And what attention or self attention allows us to give different amount of weight to each of the token embedding based on the conceptual idea it is bound in the text. And if you talk about the token embedding, and in the bot that was generated, that was developed by Google, each token is represented as a 768 dimensional vector. And what is self attention? What is so self in self attention? The self part of the self attention refers to the fact that these weights are computed for all the hidden states. And let me briefly explain. Each word or token in the input sequences that we are given, and that the token embedding, it will be associated with three types of representation: the query, the key, and the value. The query, key, and value are the main topic of this video also. And the each token or the embedding token will be associated with three types: query, key, and value. And this representation are derived from the hidden states. So what we need to understand, that these three representation, query, queue, and the values, um, and this query, key, and value are represented derived from the hidden state of the input sequences. The input sequences are the token embeddings. And the attention mechanism then calculates the attention weight between the queries and the keys. So these query and the key are majorly importance when calculating the attention scores. We'll first talk about this in the later part of this video. And the query and the key are calculated. The attention mechanism calculates the attention weight between the queries and the key, which measures the relevance or similarity between the tokens. So which query is more relevance or more associated with which key is the main idea behind the self attention. And the main idea behind using self attention is that instead of using a fixed embedding that we generated in the first case for each token, what we can do is use the whole sequence. We use the whole sequence of embeddings and compute a weighted average. So we don't use the initially generated embedding. We can compute a weighted average of each embedding. One of the main advantages of using self attention, that it allows the model dynamically compute a weighted average. So what we need to focus, the more advantage one of the main advantage of using self attention is that it allows the model dynamically compute a weighted average. We'll talk about the weighted average with an example in the later part of the video. And that each token based on the entire sequences, this dynamic weighted average is departure from the traditional approach where fixed embedding are used for the token. So like I talk about, the initially generated token embedding are not used. Weighted average of each embedding is used in the networks, which are calculated and which gives the relevance for the each token or the each query, and which query is more associated with which key value. If it is become hard to understand, we have the second phase of the of the concept, where we will give a short example and you will understand it. So by calculating the attention score based on the full context of the sequences, self-attention can capture dependencies and relations between tokens that are relevant to the given task. Like I mentioned already, the after calculating the attention score, so we will get the idea which token is more relevant or more associated, which are more dependencies, which is more dependent to which query or the next token. This is the main advantage of using self attention. So we get to know which part of the input sequence to more focus on. um, so beside that theory, so we need to know what comes on your mind when you see this word flies. Yes, of course, insect, house flies, they are the disturbing creatures. And but is that the only meaning that flies in captures? No. So if you take this example, time flies like an arrow, with the flies has a different meaning than these flies. So what we can generalize from this, that the word same word can have different meaning as per the concept. Can so here it is noun and it is verb in this example. So in these pictures which I've taken from a book which I am currently reading, and in this picture or in this diagram, what you can know is, in the first example, here the time flies like an arrow and fruit flies like in banana. Here the flies need to be associated as source, and here the flies need to be associated as insect. So this is what self attention can do. Based on the concept, it can give weightage to the same word on different meanings. So how do we calculate the attention weight? We have talked about the theory, but how can we calculate the attention weight? So first step is to prepare the input embedding. Like I said, the bot gives 768 dimensional input embeddings. So first is the same, we have to calculate the prepare the input embedding based on certain dimensions. So it all depends on what type of dimensional you are taking. So if we take bot, it gives 768 dimensional. And the second step is to compute the query key and value representation for the given embeddings. For each token, derive this representation query key and value. So in the example, you will know how to derive this representation. And then the second step is to calculate the similarity score. The similarity score is nothing but a black box. No, not black box. It is just a dot product multiplication of query and key. So query is also a vector, key is also vector. So we can simply do dot product multiplication of query embeddings and key embedding, key vectors and query vectors, and what we get after the dot product multiplication is our attention score. And after calculating the attention score, um, the dot product of the dot product of this similarity function or dot product multiplication in general produce arbitrary large numbers. So we don't want that large numbers, so we need to which can destabilize, we can make the training process destabilize. So we need to lower down this, we need to handle this and normalize this their variance by multiplying with scalar factors, and then normalize with a softmax function to ensure that all the column values sum is equal to 1. The sum of all the values need to be 1. So the resulting n by n matrix now contain all the attention weight, that is Wji. Don't worry about this. We have an example. And the last step is to update the token embedding. That is the first the initial this will be the initially generated token embedding, and this will be the attention weight generated, and this will be the updated token embedding, the coefficient wj attention weight, like I mentioned. And this will be the summation j is equal to 1 to n wji will be 1, because we have already normalized it using a softmax function. So let's go through in third phase, that is with the example, and we have taken a following sentences as example: the cat sat on a mat. So we need to tokenize it: the cat sat on the mat. So first what we said, we need project each token with the embedding. So what I have taken is 1 by 3 embedding. I have taken 1 by 3 embedding, that is three-dimensional embedding for the embedding of each of the tokens, that is dog, cat, sat on mat, is this this is the randomly generated tokens, embedding 1 by 3 embeddings. So the second step is to consider a query. In this case I have taken the cat as a query, and I have to, what I need to do is, in this case what I need is to calculate which other tokens are more dependent or more related with the cat, or the tokens token cat. For this I have taken cat as a query and every others tokens as a key variables. So in, we need to calculate the query vectors. I forget to this is query vectors, this is query vector, this is query vector, sorry for my handwriting. This is query vectors for the cat, and this is calculated, the query vectors for each token is calculated by the multiplication of the initially token embedding into that is weight of query vectors. Then the weight of query vectors is nothing but a matrix of dimensional embedding vector dimension to a query vector dimension. In this case that is 3 by 3. So we calculated query 0 0.8, 0 0.1, 0 0.3. This is text embedding with WQ, that is 3 by 3 matrix, and calculated these query vectors. And after that what we need is to calculate the similarity scores for the in this case our query is cat, and key are other elements. So we need to calculate the similarity score between the query, the cat, and other tokens, that is key. And we calculate the query vectors with the dot products, and got these attention scores. So after that what we need is to calculate the attention score for each of the corresponding value, that is, this can be calculated by simply multiplying the attention score that is just calculated in the previous slide, and multiplied with the initially generated, that is token embedding, that is, this is the initially generated token embedding, and this is the attention score, and what we get is the updated token embedding, and this can be used in our neural network. So what is the main after the what is the difference between using these token embedding to main this attention embedding to initially generated token embedding, is that in this embedding it is calculated the attention, it is multiplied with the attention score, attention weight, and it has more idea which token to give more attention to, and this is how attention is all you need. The research paper was calculated. I hope you understand it, and see you in the next video. And for the references I have the first paper is, of course, the attention is all you need paper, and second is the book which I am referring to for my study. Thank you. See you in the next video.